In this video, I'm going to review some of the math that it takes to be able to double your savings. Some of it's going to be kind of a review, some of it might be a little new. This will come back when we start talking more about maybe investing and interest and different things like that. But for now, we're going to just review it and then focus on one concept in particular. So, key ideas. When there's different kinds of interest we talk about compounded continuously and compounded after a certain amount of time. So continuously means that literally at any second, at any minute, at any time, you should be able to take the interest of something. It's continuously happening. Whereas a compounded every certain amount of time means you're given at a certain time, interest is taken. So that could sometimes be annually, which you'll see most often. You'll see it quarterly, which is 4 times a year. You'll see it semi annually. You'll see it maybe monthly. And I think those are the most common, but sometimes you might see something like weekly or something like that. I would say those are the most common. So, what does this mean? So, continuously again means that at any time it's always being taken. And the difference between these equations that we use for these to find out what our interest or what the interest rate looks like over time varies like this. So, for continuously, A equals P e to the RT. Now, E is its own entity, it's its own function. So, when I'm putting it in the calculator, when I'm talking about continuously, we look for the E button on there because it is its own function. So, it's defined as its own function. Whereas over here, we're looking at A equals P1 plus R over N to the NT. So, what do each of these mean? So, for both of these, my A is the amount that I get after a certain amount of time. And then both have R, or I'll go with P first. P is our principal, which is also our starting amount. So our starting amount is how much did I put in the account initially? From there, I have R, which is my rate. We need to always write this as a decimal. And then in this one, the difference is that I have N, which is the number of times interest is taken. And this is usually referring to within a year. So if it's monthly, N would be 12. If it is quarterly, it would be 4 times. If it's semi-annually, it's twice. And if it's annually, it's once. So that's what N is representing. So the one we are focusing on is given a certain amount of time. The ones in your worksheet are going to be specifically annually, but I will do an example that is not annually just so you can see it. So, an example would be if I'm investing $2,500 into a savings account, and the savings rate is 1.6%. And I need to know how often. Let's say it's compounded quarterly. So my first question is, how much would I have after, let's say, 4 years? So in this one, it makes it pretty simple because I don't have to do anything fancy. I'm going to identify my A, I'm going to identify my P. So this is my P value. I'm going to identify my R, and I'm going to identify my N. And now I have my T right here. So I can say A is equal to 2,500, 1 plus my rate, which is 0.016. That's how we write 1.6%. We move the decimal over to the left twice, divided by the number of times I'm taking this per year. Quarterly means I'm taking it 4 times, so I'm going to write a 4 underneath, and then raise it to the n times t power. So after that, I get 2,500 is equal to 1.004 to the 16th power. So when I put this in the calculator, I find that I get approximately $2,664.89. So we end up rounding it a bit. So what if I want to know about doubling it? So if I want to doubling my principal, this is when it gets a little tricky. So there are these things called logs, and what logs do is they are the opposite or the inverse of any kind of exponent. So logs or log functions are inverses of exponents. They undo each other. And I know in the video that's provided for you on the worksheet can be a little confusing. So I'm going to show you the way that I would do it exactly in this situation. So if I want to double my money, I want my A to be $5,000, since that is the equivalent of 2 times 2,500. So that means that I have $5,000, and I want to know how long it's going to take me to get to this point. So I start out with my 2,500. I have my 1.004 from the previous. I have my 4, that was my n, but I need to figure out my time. So what I'm going to do is I'm going to take the log of both sides, but before I do that, I'm going to divide both sides by the 2,500. So always going to divide by my principal first. And you should notice that we always end up with 2 on the left-hand side, and then whatever we are raising to the power on the other side. So this is always going to be that next step. 2 equals whatever 1 point your interest rate to some power. So from there, I need to take the log of both sides. So that means I'm saying log 2 equals log 1.004 to the 4t. What's nice about this, instead of listening to that video of how it was explaining everything, this is what I would do. When I have an exponent with a log, this just gets moved up front. So I actually end up with log 2 equals 4t times log 1.004. So to get 4t by itself, I'm going to divide both sides by log 0.1004. So log 1.004. So then in the calculator, I get something along the lines of 173.633 is equal to 4t. From there, I would divide by 4 to get rid of the 4 on that side to get t by itself, and we'll find that t is equal to about 43.4 years or so. So when you're doing this, you don't need to overcomplicate this and add any kind of different change of base or anything. Just rewrite it, bring the exponent out in front, and then divide by the log that's on this side so you can solve for t. Now the ones in your problems are all annual, so it should end up being t equals whatever the amount of time is supposed to be, which is fine. The rule of 72 works, but it only works if it's taken annually and not something else. So that's why the rule 72 works, but not if it's quarterly, semi-annually, or monthly. So I just want you to remember that.